Okay, this video is for problem number 4 on stoichiometry worksheet number 6. The first thing it tells us to do is balance the following equation, and it gives us this equation. So if we take a look over this equation, there are a couple things that we can see. And again, you can balance this out using the long process, but I can kind of do this in my head, so I'm just going to do it fairly quickly. Right now, I can see that there are 4 fluorines in the products and only 1 in the reactant, so I'm going to go ahead and put a 4 right here. That's going to balance the fluorines, but that also gives us 4 hydrogens in the reactants, where there's only 2 in the products. If I put a 2 right here, that gives me 4 hydrogens in the products as well, but that does change the oxygens to 2. Luckily though, there are already 2 oxygens in the reactants, so that's good. And then if I look at silicon, 1 and 1, so we're good, we've balanced. Now, we can actually work the problem. It says if 15 liters of HF gas at standard temperature and pressure reacts completely, what mass of silicon fluoride is produced, or silicon tetrafluoride? So we're given 15 liters of HF gas at standard temperature and pressure. And it wants us to find the mass of SiF4 that could be produced from this. So if we look at the molar map, the first thing that we need to do when we start with liters is convert into moles using the relationship of how many moles are in, or excuse me, how many liters are in 1 mole of gas. Remember that 1 mole of any gas is going to be equal to 22.4 liters at standard temperature and pressure. So what that means, if I want to cancel out liters of HF, I can put 22.4 liters of HF in the bottom of the conversion. And I can put 1 mole of HF in the top. This will cancel out this unit, and right now we're going to be left with moles. We need to keep going though, because we're trying to convert into the mass of this substance. So we're going to use the mole ratio next. That's what the molar map tells us to do, because we need to convert from moles of HF first into moles of SiF4. If I want to get rid of moles of HF, I'm going to put that on the bottom. I'm going to put moles of SiF4 on top. Remember, I pull these units from the balanced equation. 4 is the coefficient on HF, 1 is the coefficient on SiF4. And then the last thing that it tells me to do in order to convert into mass is to use the molar mass of this substance. The molar mass, remember, is how many grams would be in 1 mole of the substance. So we need to figure out how many grams of SiF4 make up 1 mole of SiF4. And then in order to do that, we use the periodic table. Whoops. All right. In this compound, we have 1 atom of silicon, which we can do 1 times 28.09. We have 4 atoms of fluorine, so we need to multiply its molar mass times 4. Its molar mass is 19. So that tells us that in 1 mole of this compound, we would have 104.09 grams. Now, I wrote it this way with grams on top and moles on bottom so that moles of SiF4 will cancel. We can actually go through and see this will cancel because there's 1 in top, 1 in bottom. Same thing here, 1 in the bottom, 1 in the top. The only unit that we are left with now is grams of SiF4, which is what the question's asking us for. So now we can just do our math. Multiply across the top, 15 times 1 times 1 times 104.09. And in the bottom we have 22.4 times 4 times 1, so 22.4. Oops. All right, well, let's start all the way over then. 15 times 104.09. And in the bottom, 22.4 times 4. That gives us 17.43 grams of SiF4. So, if 15 liters of this substance go into the reaction, this is how many grams of this substance should be produced.